Okay. Hi, everyone. I want to start by just recording just some video first before we get into the chapter, because this chapter, which is new, is chapter 14 now. We're in the last chapter of the semester, which is exciting. Um, it's actually pretty different than everything else we've done so far. So 10 was like foundational material. 11, 12, and 13 all tied together really, really well. Basically, it was setting up what units mean, and then we got into talking about two and three-dimensional objects and characteristics about them. But now we're actually going to go back to talking about things in the plane, and this chapter is more about manipulating objects. Everything else we've done is here is an object, compute something about it, or here is an object, describe something about it. But now we're actually going to be talking about things moving around, things getting transferred, which personally I'm excited about. This material is always some of my favorite material that appears in classes. So I'm excited to teach it, and I hope you guys find it interesting and enjoyable. Um, but yeah, the main thing I wanted to comment on is what we're doing now. I think everything has felt very connected. This stuff is going to feel a little different at first. The other thing I wanted to comment on is a lot of stuff in this chapter is going to use stuff from day one, 10.1. So parallel postulate, what angles mean. If you're not comfortable with those things, you may want to refresh. I think today you'll be fine, but in future days, um, it'll be helpful to have refreshed those. So with that in mind, let me switch us back to the notes. All right, here we are, first section. So this first section is about transformations of the plane. In particular, they're about reflections, translations, and rotations. So first of all, so all of these things we're talking about in this section are called transformations. And a transformation of the plane is just, it's a way to literally, it's probably a useless definition, but I wrote it down anyways. It's a way to transform the plane. What I mean is I'm gonna like move the plane around, I'm gonna shift things, rotate them, reflect them. I'm gonna do all sorts of things. So everything we talk about today is a type of a transformation. In particular, we're going to focus on three transformations. And for all of these, I'm going to give you informal ideas and try to add a little bit of rigorousness to it. But I think that the way I'm going through this material will be good enough for you to understand what's going on. I just think we don't need to start off overly complicated. Oh yeah, and before I get too far into it, one comment I have is that it might be nice to, if you're not going to take notes and you're just going to listen, I still recommend if you have graph paper to print out some graph paper. You can also just print out these PDFs and just work off the graph paper on here. This grid background actually appears um, when you print out the PDFs, I believe. So do what you will, but I recommend having this graph paper handy because it'll help you when you're doing these problems today. Okay, let's get into it. So our first transformation of the plane is called reflections. I think reflections is the most basic one among all of these. Um, so for each of these transformations, I'm going to specify what data we're given, what we start with, and what happens with that information. So what are we given? We're given a line of reflection and a point. So looking at my example down here, this is my line of reflection. I abbreviate it with LOR, and I'm given just some point. So here's my point Q. And what happens when I reflect? And I give a very vague description. I just say the point is reflected across the line of reflection. So intuitively speaking, without being too rigorous, the idea is that you have your point, you have your line, and it's like imagine you were looking into a lake, right? And you see the mirror image. And actually, let me make that yellow. Let's call this Q prime. So Q prime is the reflection of Q. So what is the rigorous details we need here? So first of all, I want you to notice that this dashed line I made is perpendicular. Sorry, let me make this a little skinnier. This line right here is perpendicular to the line of reflection. So that dashed red line needs to be perpendicular. Okay. So what else is important? It's also important that this distance here and this distance here, those need to be the same length. And if you think about what reflection should mean, this should kind of make sense. If you were looking in a mirror and you saw your reflection and you saw something standing behind you, if there was, let's say you and your friend are standing, one is closer to the mirror than the other, you expect when you look in the reflection for the person who's closer in the mirror to still look closer in the reflection, right? Reflections reflect what you see. So things that are farther away should still look farther away in the reflection, and vice versa for closer things. So it's really key here that this distance up here is the same as that distance down there. Okay? And that's basically what I mean by reflection. In this scenario, we say Q prime is the image of Q under reflection. So this word image is going to come up a lot. So when we say image, the word image does come from something mathematically, and so the word does make sense. Image generally, for those of you that have played with functions, we sometimes call the output of an input, we call it sometimes the image of that map. So that's where the name comes from. But basically the point is when I say Q prime is the image of Q, that means I transformed Q. So i.e. we transformed Q by reflection to get Q prime. Okay, that's all that word image means. Okay, so here's a problem for you. So please pause the video, copy this example down unless you have the notes, and draw the images of P and Q under reflection, where M is the line of reflection. Okay, so go ahead and pause now and don't spend more than 2 minutes. 2 minutes. Go. Okay, hopefully you were honest again and paused. So let's do it. So remember, the idea is that, so let's start with P here. You draw a line perpendicular from P down to the line of reflection, and then you duplicate that distance. So I'm not looking for anything precise here. So that should look about right to you. And now let's do the same for Q. So again, in this scenario, I don't need you to be too precise. Okay. Okay. So hopefully your picture looks something like that. For now, it's okay that your pictures aren't perfect. Remember, the idea is that this length here and that length there, those need to be the same. It's obviously not really possible right now to do, but eventually we're going to do problems where this is possible. But for now, again, like I said before, I'm just starting with like the big picture of these transformations. Okay, so now for the second big picture, translation. So this is our second big picture transformation object. In this case, we're given three things. We're given a distance, a direction, and a point. And what happens is the point is moved in that direction and distance. So that might seem kind of straightforward. So sometimes what we'll do is we'll use arrows to represent a direction and a distance. So I'm going to translate both of these points using this arrow. So this arrow says, take your point, go down 1, and then go left 2. That's what this arrow says to do to each point. So in this case, the direction is like going that way, and the distance is captured by how long the arrow is. But I can decompose it into these two smaller pieces. So now let's do that. Oh, and my points are in the wrong place. Okay, well, I'm gonna have to cheat here. Sorry about that. Ideally, these points would have been, actually, let's just go ahead and redraw it. That's not bad. You might have to redraw this in your notes. Okay. All right. So what's the point? So now this guy is going to go down 1 unit and over 2 units in that direction. So right here is where Q prime appears. By the way, there's nothing special about using Q prime as the image. Like I could call the image R or T if I wanted to. It's just nice to use the same letter and then distinguish it in some way. All right, and then the same thing is for P. There we go. No. There's P prime, okay? That's all I mean by translation. Translation literally means I'm just moving it around. So while reflection reflects across something, translation means I just literally move it in some direction. So I guess I said reflection was the nicer one, but I think translation is probably the nicest. And then reflection's the second nicest. And then this last one's, I think, is probably the trickiest, rotation. Given rotation, so given a center of rotation, an angle, and a point, what you do is you take that point and you rotate it about the center of rotation by the angle. So I have an example for my center of rotation and my point. So my point's Q. So here's what you're going to do is you're going to draw a line here. And let's say my angle, and I don't have an angle anywhere on the page, but let's say my angle was 45 degrees. So I'm estimating here that about that arc is 45 degrees. So this should remind you of something we did on day one when we were talking about what does an angle mean. What does it mean to have an angle? It means I like rotate about a center by so many degrees. So I want to imagine that, you know, using this arrow, for example, I am going to like literally sweep through this 45 degrees. And that's how I rotate, right? I start like this and I just rotate around. I'll do that animation one more time. So 45-degree rotation around this would be like this. So what ends up happening is we end up right here. Sorry, yellow image. There we go. And that Q prime is the image of Q under rotation. Okay. That's just written out. Okay, there's one more very, very important thing here. So the angle is captured here, but there is technically one more really important piece of information. Just like in the case of reflection, these need to be the same length. Right? When we think about rotating something about a point, I don't want it to get farther away from the center. The distance from the point down to the center should not change. All I'm doing is just rotating it around. Think about like an orbit, right? All the planets orbit around the sun. I mean, yeah, okay, bad example because planet orbits actually do get farther away from the center. But the idea that I'm trying to get you to see is that when we say rotating about a center, I don't want my distance from the center to change. I just want to rotate around it. And maybe just to kind of help with this, whoa, the basic point is that we are like, the idea is that we are ending up on a circle somewhere. So like, it's not a perfect circle, but that's the idea, that when I rotate about this point, I end up somewhere on this circle, but where depends on the angle. Okay, so this has just been a basic overview of our three transformations: reflections, translations, and rotations. But now I want to be a little bit more careful and rigorous, because in all of these pictures, I wasn't like really exact, right? On this one, I approximated. This one, I was able to be exact, but that was only because I was working with a pen and a tablet. And in this one, I was like being like kind of loose about if it looked perfect or not. But now I want to work with examples where we can actually get them to look perfectly. And also, I don't want to just rotate points. I don't want to just translate points. I don't want to just reflect points. That's kind of boring. I would really like to transform objects, something that looks like this. So how do we transform a very complicated looking object? And the idea is to just transform every point. If you transform every point in the object, that's what it means to transform the whole object. So the point is, we define how to transform points first, and then when I want to transform a more complicated object, I just transform every point in there. So let's start by translating this picture in the direction given by the arrow. So again, the arrow's not, I don't know why that happened. I fixed this before I started. The arrow is supposed to go right 3 and up 1. Okay. So how do I transform this object? So this object is big, right? It's this big. And the thing to keep in mind is I filled it in. That means there is like, you should be thinking about this as like there's a bunch of points living inside the shape. And you should be thinking, oh my God, I have to shift all of these points? That does seem a little hectic, right? But the good news is that just because of how this shape looks, translating shapes doesn't really change how they look. Really, I just have to figure out where these points go. If I can figure out where P, Q, R, and S go under this arrow, the whole shape's gonna basically follow. And so P, so remember, this goes over 3, up 1. So 1, 2, 3. So that's where P prime will be, right? And so Q prime will go 1, 2, 3, 1. And then again for S, 1, 2, 3, 1. Then 1, 2, 3, 1. So that's S prime and that's R prime. And now if I connect up all these points, whoops, that last one wasn't perfect. This shape should look similar to the shape we started with, right? What's the only difference? It's just translated somewhere else now. So translating objects actually isn't that bad. You just have to you just kind of have to find these like outside points first, just translate those few points, and then just draw in whatever lines appear. So in a technical sense, translating objects should be a daunting task because there are infinitely many points in some objects. But at the end of the day, we can utilize how nice the picture looks to figure this out. Okay. And just to make sure you can see, we have copies of this arrow everywhere. Okay. So if I actually was to pick up this arrow, oh, that's too much. It's fine. We don't need it. Okay. Cool. So that's what translation does. Now I want to talk about this next part. What is the image of 3, 1, 2, 4, and AB under this transformation? So 3, 1, um, so some of you have seen this recently, others of you probably haven't seen this in a while. So I have these axes here, right? This axis right here, that's the x-axis. This axis up here is the y-axis. And when I plot points, I plot them as a x and a y. So the first coordinate tells me the x position, the second one tells me the y position. So 3, 1 is r because it goes x is 1, 2, 3, and the y value is 1 because it goes up 1. So that is technically r. And 2, 4, if I go 1, 2 on the x-axis, and then 1, 2, 3, 4, that point is P. Okay. So what is the image of 3, 1? Well, we know we can like just literally find it in the picture, right? We can see r prime is right here. But if we wanted to be careful, we could just do what this translation does, and it says go right 3 and go up 1. So I go from 3, 4, 5, 6. So the x value becomes 6, and then I go up from 1 to 2. So the image of 3, 1 is 6, 2. And then the image of 2, 4 is, well, we just do the same thing, right? I start at x equals 2. I go over 3, which means I'm now at 5. And then I go up 1. So I go from 4 to 5. So what about for a general point, AB? What are we always doing? No matter if it's 3, 1, 2, 4, it doesn't matter. What we always do is we go right 3 and up 1. So we say we take our x value and I add 3 to it, and then I take the b value and I add 1 to it. And if you look back above, we can actually see that this works. 3, I added 3 to get 6, and 1, I added 1 to get 2. And then here 2, we add 3 to get 5, and 4, we add 1 to get 5. So in general, the point AB, this arrow up here says increase your x value by 3 and increase your y value by 1. Okay? That's the idea. Take a moment, maybe pause, make sure you're okay with that. Okay, now let's do some reflections. So before, reflections were a little bit vague, but now we can be more concrete. So remember, reflection, I need to be given points and I need to be given an axis of rotation. So we're actually going to do 2 examples in this. We're going to do an x-axis reflection, and then we're going to do a y-axis reflection. So when I say x-axis reflection, that means I am treating the x-axis as the line of reflection. Okay? So how do I reflect? Remember, the point is that we draw perpendicular lines to the axis of reflection from the point down to the reflection axis, and then I have to travel that same distance. So notice before I was very vague about the distances, but now we can see that the distance is 2, right? We go up 1, 2. So that means I've got to go down exactly 2 to get the image, right? And then same goes for this point, right? It goes down 2, so I've got to go down 2 again. And then this point right here is 1 above that point I just drew, so it should be 1 below. Because it's farther away, it has to travel 3 units, right? Goes down 1, 2, 3. So it's got to go 1, 2, 3. This guy over here travels down 4. So this goes 4. I'm just going to start cleaning up this picture just so it doesn't get too busy. I think by now you see the idea. This top point here is 5 above, so it drops down 5. Okay. So notice I never changed the x values when I did this, right? The x values stayed exactly as they were. It was the y that changed. They went from above the x-axis to below. And now I can just draw in. As you can tell, I already gave up on using the perfect looking lines. And this should look like the exact same picture, you know, accepting the fact that my picture isn't exactly perfect because of my drawing, but it's the same picture. It's just reflected down lower. So that is the x-axis reflection of the image. And now let's do the y, and it's going to be the exact same process now, except now I'm reflecting across the y-axis, which means now my lines are traveling this way. And that point travels 2 to hit the y-axis at a perpendicular line. So it travels another 2. This point right here travels 1, 2, 3, 4 to get here. So it's got to travel 4 again. Okay, and you can just continue to do this to get the following picture. Again, I'm just going to clean up. Okay. And there we go. So we've reflected this across 2 axes. And just so that we're all on the same page, if I label these P, Q, R, S, T, then this is the thing that's P prime, that's Q prime, that's R prime, that's S prime, and that's T prime. And then over here, because I already have 1 primes, I'll use double primes. Okay. So those primes are just meant to help you track which points are the images of what. Okay, so that's how we can make reflection more concrete. And now we know this picture is like really exact. When we did the stuff at the beginning, I'm going to scroll up for a second. When we first started with reflections, I was like guesstimating those distances for reflection, right? But now what's really nice is like I can be exact because of the axes I'm picking. I'm picking nice axes. Do know how to generally do it for any axis, at least in estimating it. But when I give you an axis, I expect the picture to look pretty close to perfect like mine does. Okay. So now let's answer some questions. What is the image of -2, 2 under y-axis reflection? So let's figure out which one's -2, 2. So -1, -2, 1, 2. So that looks like that's P. So image of P. So where does that get sent to? So, oh, whoops. I just caught a mistake. This is Q double prime, and that's P. Wait, this is P double prime. Okay, that was probably very confusing. I will make a note to make sure you guys know that I caught that before. Problem 2. Because I'm sure a lot of you will get confused and then be like sending me emails, and I'd rather you know right away than being stuck at one point in the video. Okay, is everyone okay with that? I'm asking as if you can tell me. If this is P, then it travels 2, so it goes 2 more, and that's where P should be. Okay. All right, so where is the image of P? So it traveled across the y-axis to get here, right? So that's now positive, x is now positive 2, and I still go up 2. So that is 2, 2. So what about -4, 4? So let's go 1, 2, 3, 4, 1, 2, 3, 4. So that looks like it's the image of S. By the way, I'm just putting letters here just to help you associate the coordinates with where they are. You could easily just put -2, 2 here and -4, 4 here. I don't care about that. I just think the letters might be helpful. Okay, so where does S go? Well, like we said before, S travels a distance of 4, and then it has to travel that distance again. So when it does that, it ends up at 1, 2, 3, 4, 1, 2, 3, 4, 4, comma 4. So look at the points. What's happening to P and S? I go from -2, comma 2 to 2, comma 2, and -4, comma 4 to 4, comma 4. So what's happening every time? You should notice that the y values, the second coordinates, these stay the same. But the x values, those are getting flipped. And it makes sense that they're getting flipped because over here, this side of the x-axis is always negative. This side of the x-axis is always positive. When I reflect across the y-axis, it has to take me from the positive side to the negative side. Or if I was already on the positive side, it would take me back to the negative side. So the image of AB is we keep the output the same, but we negate the input. So this is because when we reflect, we need to be the same distance from the x-axis, the y-axis, but on the other side. That's like an explanation for why it should be negative AB. We were on the negative side, but now all our x values need to be positive because I'm on the other side of the y-axis. And again, all the negative x values are here and all the positive ones are here. So it might be confusing to you that we're doing a y-axis reflection, but what's changing is the x values. I think that's possibly a little bit weird, but don't let the fact that it's a y-axis reflection mean anything more than instructions of how to reflect. When we reflect across the y-axis, all that really says is that our x values are changing. Okay. I want to go back up for a second. We never really explained why this is what it is, but the point is because the arrow says to go right 3 and up 1. There are some problems on the homework where you're expected to give an explanation for I think on some of these problems you'll be asked what happens to AB and explain your answer. And I just want you to say something like this, just to make it clear that I'm going right 3, and so I have to change the x values by 3, and then I'm going up 1, so I have to change the y values by 1. So, okay, cool. All right, I now want you to pause the video and just give yourself a chance to practice reflecting. So don't worry about the giving me what the images of P and S are. I just want you to practice reflecting across the y-axis and reflecting across the x-axis. So go ahead, pause the video and spend no more than 3 minutes. Okay, so let me be consistent with my colors. So for the x-axis reflection, my points should look like this. So again, all I'm really doing for my x-axis reflection is seeing the distance to the x-axis and just flipping it over, right? That's all I'm really doing for those. So there's the x-axis reflection, and then the same idea goes for the y-axis reflection. One comment I want to make at some point is, even if you've never actually done this mathematically before, you do know what reflection means. I'm sure you, like I said, you've seen yourself in a mirror, and that mirror image is always a reflection of yourself. You've seen yourself maybe looking into a lake. You have good intuition for what reflection means. So if the picture doesn't look quite right, your intuition might help you here. So let your intuition help you, but don't let it take over. Remember what the actual definitions are. Okay? All right. Let's do this problem together. What? Okay, I'm sorry. Everything just freaked out on me on my end, so I'm going to go back to sharing the screen, and I'm going to hope nothing bad happened. Just to recap, so I will fix this later if it's not correct, but just to recap, here is the answer for this one. Okay, I think I might have just accidentally hit the stop sharing button. It looks like we're still recording, so that's good. Okay, now rotation. Rotation is a little bit trickier, but you're always gonna have very nice angles to deal with, and that should be helpful. Okay, so how do I rotate by 180 degrees? So remember, and we're rotating about the origin. So the origin is always 0, 0. So that's the blue mark I marked. So there's our center of rotation. We're rotating by this degree, and here are the points. We've got 5 points to rotate. Okay. So let's just do this systematically one at a time, and I think it won't be too bad if we do it one at a time. Okay, so let's start with Q. So how do we rotate again about a point? Let's draw a line, and now I want to form a 180-degree angle. Remember, 180 degrees forms a straight line. And now this distance here gets moved over here. So 1, 2, 3, 1, 2, 3. So 1, 2, 3. So Q prime, let's do our images in different colors. Here is Q prime. Okay? That one shouldn't be too bad. Let's do one that's a little bit harder. So P, I'll get rid of the extra stuff. There is the line from P to the center of rotation. And now I need to have a 180-degree rotation about this point. So I've got to go around. But the point is I've got to make it 180 degrees, which remember is a straight line. So actually, I should be able to say that it goes exactly here, because this dashed red line right here is really a straight line, but it's a straight line because this degree of rotation is 180 degrees. So that's what's really nice about 180-degree rotation, is what you're really doing is just drawing lines through the origin and then just letting them continue. So that is our P prime. R looks like this. So what does R do? It goes over 1, 2, 3, 4, 1, 2, 1, 2, 3, 4, 1, 2. So if you're not sure what I'm doing there, I figured out the coordinates for r, because the line goes, the slope of this line, or how steep it is, it goes right -4, and it goes down 2. And because there's a straight, because of the 180 degrees thing, it's got to be a straight line still. All right. And you can continue to do this, and I won't go through the details to get these two images. And so what you end up with is a 180-degree rotation through the origin, or about the origin. So there is our rotation. So you literally should be thinking about this as this guy is being taken and it's being rotated around the origin 180 degrees. So it's literally like, literally think about taking this object and spinning it around, like it's like traveling around in this like circular manner. And to actually help, no, I think that's fine. Yeah, so one thing I recommend you do right now as a little experiment is, especially if you have this printed out, I recommend you take the page right now and literally flip it around 180 degrees. And when you flip it around 180 degrees, these guys are going to switch places perfectly. Flip it around on your page and then compare what you see on the page to what you see on the screen. It should look basically the same, except the letters are upside down and the colors are flipped around. And that's because that's actually how you could figure out if you've rotated correctly. If you take your page and you flip it around, that's going to be perfect. Okay? So now let's do some of these practice questions again. So what's the image of -2, -1? So -1, 2, 1, that's P. So the image of P, where did that go? So that got rotated around by 180 degrees and it landed at 2, 1. What about -4, 2? So that one's our image of R is, and again, this got rotated around by 180 degrees. So that's like the path. What I'm drawing right now, that arrow, that's kind of like the path that it follows when it's rotated. So this is where, before we started this lecture, I told you that this section is kind of about moving things around. So literally things are like spinning around dynamically. And that's where R lands. It lands at 4, 2. So where do you guys think AB will land? Image of, I guess it's nice that I ask rhetorical questions like that, but it's like, I definitely keep asking these questions as if you guys are about to respond to me. So when I say these things, I'm definitely not expecting responses, obviously. Okay, where does AB go? So what happens to both of the coordinates? So it looks like from the picture, both times things are getting negated. So it'd be nice to have an explanation. And do you guys remember me telling you to flip around your page? So actually, no, I'm not sure this is going to work. I'm going to try it. Oh, no, it won't let me. I was trying to rotate my screen in the recording, but it won't let me do that. So why is this going to be what happens? Well, think about what happens when you actually take the plane and you flip it by 180 degrees. When I take, so I literally want you to think about spin the whole 2 axes around. The positive version of the x-axis will end up getting flipped around to the negative side. The negative side will, of course, get flipped to the positive side. And the same with the y-axis. So the point is that this is because rotation by 180 is equivalent to making, or is equivalent to flipping the axes so that positive x becomes negative. And vice versa, also for y. So I just want to like write down a relatively concrete, this is still a little vague, I'll admit, but I just want to like show you guys that we can make it relatively, we have a relatively understandable argument for why this happens. What's happening is I'm taking my axis and I'm like flipping them around so that the positive becomes negative and vice versa. All right. So why don't you guys try this one? It's a little bit trickier, but now I want you to rotate by 90 degrees clockwise. So clockwise is like what this little arrow right here is doing. Everything's getting rotated like this, like the direction of the clock. So pause the video now and see if you can do it in 2 minutes. Okay, let's do it. So remember that we still have our origin as our center of rotation. That's why I wrote the word same there. And now I want to rotate everything by 90 degrees. Let's start with P. I think P is the easiest one to rotate. So here's P. As for Q, you could estimate what 90 degrees is from here. You should expect 90 degrees. Remember, these are right angles, right? So you should expect it to be something like this, but you can actually be precise. Because, and if you're not convinced by this, rotate your page by 90 degrees clockwise and see what happens. Basically what's happening right now. So notice with the P prime, over here, P had an X value of 0 and a Y value of 3. Now notice that the X value became 3 and the Y value is 0. Similar things are going to happen here. And that now instead of going right 3 and up 1, it's going to go down 3 and over 1. Okay. If you don't get this, this isn't the most important part of this all. So don't dwell on this too much. I just want you to have some intuition. You know, it's especially hard since we're not like in class where we can talk together about this. Okay, so for R, same idea holds. It goes over 4 up 3. So let's go. Yeah, so let's do this. We're going to go down 3, or over 3, down 4. Oops. So we end up with this shape. This one was probably a little bit harder to do on your own, but I think it's important to like try to think about things before listening to them. It helps you know where exactly you need to figure things out. Okay. One thing I'll point out is notice that the line between P and R is now a vertical line, and before it was a horizontal line. And if you think about rotating a horizontal line by 90 degrees, it should become vertical. So that's like a good sanity check. Okay. And so what's the image of 3, 1? So that's Q. This one became 1, -3. What happened to 0, 3? It became 3, 0. That was P. So what's happening in general? So one thing to note that I've already mentioned is that A and B are getting flipped around. This is kind of like somehow encoding a 90-degree rotation, and it's not quite clear why, but those aren't details we're gonna dwell too much on. Okay? But it's actually a little bit more than that, because it looks like while sometimes this value stays the same, the output becomes the input and stays the same, the input becomes the output but has to get negated. As for a reason why, I'm not gonna like write down something detailed here. I'd rather you guys think about it, but think about what happens to the axes. And by the axes, I mean the X and the Y axis. Where do they land when you do this rotation? In particular, the X axis becomes a negative Y axis, right? Because we're rotating like that. And notice the X value, the X value became a negative Y value, right? So the X value became a negative Y value, just like how the X axis became a negative Y axis. Meanwhile, the Y axis, the positive Y axis becomes a positive X axis. And so the positive Y value stayed as a positive X value. Okay, so I'll leave you to fill in those details. I'm not looking for something very, very precise here. I just want you to share some of your ideas and thinking about what happens to the axes. Okay, so don't get caught up in this. I think it's more important that you can justify the reflections and the translations perfectly. Those ones you should be able to justify perfectly. Rotations are a little bit trickier. Okay. Okay, so that's basically the bulk of what the homework is going to look like. I have a couple more problems for us to think about just to give us a more holistic perspective. Most of the homework's pretty computational and just like do this rotation, do that rotation. I actually, before we do these, do want to make a quick comment, but let me finish what I'm saying first. Most of the homework is like that, what we just did. In fact, you basically are going to redo the kind of problems we just did for the homework. I think these two next problems, though, are better to make sure you really understand what these things are. These are more conceptual to make sure you get the big picture. Before I do that, a lot of the homework problems say something like this, like draw an asymmetric object and then do something. It tells you like draw an asymmetric object and translate it or rotate it or do something to it. Just so we're clear what that means, that just means an object with no natural symmetries. So this object, for example, this is not asymmetric because it like looks the same like on both sides of this line, right? So you want something that looks a little weird, a little wonky. So like this is pretty asymmetric. Triangles are usually asymmetric as long as it's not isosceles. This was really asymmetric. That was really asymmetric. So just, you're welcome to just reuse some of my shapes. I encourage you to try to use a different shape, but you don't have to get fancy. Just make something that doesn't have symmetry. Okay. This was one thing I didn't really love about these problems too much, because I kind of wanted them to have a little bit more just like giving you a problem instead. But, oh, there should be an extra M here. Okay, just know that that's all it is. Just draw an object and then rotate it. So you should really be doing what we've been doing on this homework. Or I'm sorry, on this class, in this class. Okay. Depending on how much time's left, if you've been doing this for 45 minutes now, I recommend you just watch. I keep forgetting to start a timer. I opened a timer this time and then I didn't start it. So we're getting there. If you're at 45 minutes, just listen through this. If you have more than 45 minutes, I recommend you pause and try to do these problems. Don't spend more than 5 minutes on both of them though. All right, let's do them. The following is not a translation by the arrow shown. Why? I'm going to go ahead and label this point here. This is P. I'm going to call this Q. And the problem is that if you notice, this point here isn't the same point as this. If you look at these two objects, this point here really looks more like this point down here, which I'll call R. And this point up here really looks like this point up there, which I'll call S. Okay. P is like the top right corner, top left corner, but Q is like the bottom right corner. And so that's the idea, is that the image of P should be S, not Q. That's basically the whole idea. And so the point is that the translation arrow should actually look like this. Whoa, 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 whoa. Should look more like that. All right. What transformations are done to the following? So this one is a reflection. And here is that axis of reflection, right? This point travels 2, 2, travels 2, 2, travels 5, 5. And this one is rotation by 180. You can kind of visually draw this line and show this is 180 degrees right here. And you can do this for the rest of them. Okay, let me make sure there aren't any notes I was supposed to say at the end. Okay, good. Okay, that's it. I hope this lecture was a little bit shorter than the other one. It felt quicker, but it's hard to say. Okay, awesome.